Hey everybody, this is Alex Merced, okay, from alexmercedcoder.com with more Scala, another video on Introduction to Scala. So in the first couple videos, I was working with Scala 2 because I had installed Scala. I forget exactly what mechanism I used to use Scala. I think I just did like a sudo apt install. So basically, again, the Scala I was using up till now was the Scala dash version. Okay, you can see 2.11. Okay, and so basically, the syntax was still very much like this, where you have to wrap your code in an object, and this syntax still all works. Okay, and then probably most places that are probably using Scala in production right now are still using Scala 2 because Scala 3 just came out not that long ago, a few months ago. But I didn't realize that there was a Scala 3. So I did download Scala 3, so I now have Scala 3. So I have them both, so I can use both. Okay, and see I have Scala 3. And Scala 3 introduces some really interesting changes. So I thought I'd just kind of revisit some of the things we talked about in Scala 3. So all the stuff that we talked about before still applies. But we have some other cool little tricks as far as like just basic setup. There's a lot of the cool thing about Scala 3 is that it did a lot to try to simplify the syntax, just make the syntax a lot easier to write and work with. And yeah, no, it's actually pretty cool. Okay, so I'm just gonna make a scratch.scala. So actually, I just make scratch.scala. So let's try this out. Actually, this will be my first run of Scala in Scala 3. Okay, but one of the coolest features is instead of having to set up this whole object, so in the previous, like I had to set up, like if you go look at the Scala code, I had to set up an object, and then the object has to have a function called main, which is totally fine. You can still do that. Again, very typical of any language that runs in the JVM. So whether it's well, I don't think you have to do that necessarily in Kotlin, but if you're using like Scala or Java or C#, which really runs in the .NET runtime, but they all kind of have this the code itself, the program itself is all within some class or object. But in Scala 3, you can make this a lot simpler by using the main decorator. So now I could sit there and make this main decorator and then define a function and say define my app. And this little annotation, because in the Java world, decorators are referred to as annotations. This becomes my app. Also, a cool thing is you don't necessarily have to use all curly brackets. So I'm pretty sure I could just write it like this. Okay, let me just take a look, go back to the reference here. Because this actually technically would be on the previous page. So let me just go back to the previous page just to see that example again. Nope, nope, it's before this even. Here we go. No. Nope, before this even. So right now I'm reading the Scala 3 book on the Scala website. Okay, so see there, so look at that. So you can define a function, and yeah, that makes it the program. So I can be like, at my app equals, print hello world. Okay, and let's see if we can compile that. So let me cd into Scala 3, cd 3, and then let's just do Scala 3 using the Scala 3 compiler. Scala 3 scratch.scala. Okay, and cool. It actually just runs it, so that's even better. So I don't have to like generate all these files unless I want to compile it, which I can then compile it with the Scala C compiler. Thing is, I think the Scala C compiler here still is referring to dash version. I think it's still referring to like version 2. Yep. So I'd have to figure out how to shift that over to 3. I could probably find a way to compile it with 3 command. So let's just see here, dash help. Okay. Scala options B, print a synopsis, color is there like an output. Scala.js, compile in Scala.js modes. Okay, That's cool. Scala.js basically allows you to compile to JavaScript instead of. So that's a neat thing I learned about. Okay, and then they even have a compiler where you can just compile to where you can compile to native code with Scala native. So let me just see here. Compile Scala.js mode. Pass an option, print synopsis failed, default colored output, default always, deprecation encoding, encoding, specify character encoding used by source files. Okay, well that's all fine with me. Okay, add text file containing compiler arguments, version, verbose. I'll have to sit there and like read up more in the CLI. But that is cool. Okay, you can just basically write your program like that. That's pretty neat. And another thing to kind of appreciate about like Scala. So again, I could still just wrap this all in curly brackets. Let's confirm that that's the case. Print hello world. Nope, that gives me some errors. Let's see why. Expect equals. Oh, I forgot the equal sign because you still got to sign it. Cool. Yep. So it still works. I can still use curly brackets. Another thing I didn't appreciate before that I want to mention now is that Scala is a expression-based language versus a statement-based language. So that means the difference between that is that control structures like an if statement actually return something. Okay, so like in JavaScript, so if I were to make like a quick JavaScript file, okay, so let's just do quick JavaScript file. Like I can't really do this in JavaScript. Const hello, where I say, you know, equals if true, hello, else goodbye. Like this wouldn't resolve to anything because this is not an expression. This is a statement. So it does something, but it does not give anything back in return. So technically I'd have to like do something in that statement that changes some sort of external variable. I have to do something side effecty. And again, Scala is a functional language, so it generally doesn't want you to have to do side effects. It wants everything you write to give something back that you can then save sort of in a new container. Now you could do this in JavaScript. I could do a ternary operator, so I could be like, you know, true, hello, goodbye, because ternary operators are expressions, not statements. Okay, but in Scala, everything by default is an expression. There is no statements. So I could do this. I could be like val hello equals if true, hello, else goodbye. And then when I print hello, it should print the word hello. I mean, yeah. So let's try that out. Okay, so let's see here. What did it not like? Print hello needs type. Wants me to type it. String. Okay. Not take parameters. Just put that in parentheses if true. Anything else it doesn't like? Then. So, oh yeah, then here. You could do something like that. Let me just take a look at the. Let's go back to where we were before. Okay. Let's try it this way. I will give this curly brackets, and then I will just say if true, because now what's happening in Scala 3, what they did is they tried to make the syntax a little bit more succinct. So you could still do like all the curly brackets you could before, but you can now do this more Python-y, lacking syntax. And so instead I would use that. So instead of using like curly brackets, I would just say, hey, this, then do this, and I'll do that. Okay, so then I would just be like, if true, then, return hello. Else goodbye. So let's see if that works now. That looks good. And yeah, see, we get hello. So you see, I can actually assign the result of this expression. So I put curly brackets, I can designate that this is an expression, and this if actually returned the value. So even though I never said return or anything like that, so point is you can use ifs in a different way. So it's like you want to make sure and then see like this is a new syntax. Like before you would have to use curly brackets. Okay, that was sort of the old way of doing it. And the question is like, would that still work? Okay, because based on that what we're just doing, and actually let me just take a look at some of the previous code we did before. Okay, boop a doop a doo doo doo. Okay. Here. Okay, so let's just do this. Use curly brackets. Curly brackets. So I've put curly brackets all over the place. Does it do what I just still work? And yes, it does. Okay, so again, you could choose to use the syntax before, like semicolons, curly brackets, and parentheses, but you don't have to anymore. Okay, so you can make this a lot more succinct, which is pretty nice. Okay, and again, with an if statement, you just have to make sure you put the then after the expression to be evaluated. Okay, cool. And again, you can have like loops, and we've talked about kind of loops before, but see, you can like do them with a lot less syntax. Okay, so before I could have just done this, but now I can do this. So I could be like, for I in 1, 2, 3, 4, 5 print I. Okay, and so basically saying, hey, for I, so it'll be like 1, 2, each one will be I, it'll print I. Let's run that. Expected better but integer literal found. But I have to create a list. Oh, because I have to make it a list. That's right. Like that's not. We're not. This is not JavaScript. There we go. We did that. Okay. Not found. I. Okay, value is not a member of a list int. Did you mean list int dot count? Okay. Print that out. Ints. Oh, I gotta specify that these are ints. Ints do print line I. Okay. Oh, wait, no, that is the list, but I gotta write do. Okay, so basically what's happened is it replaced curly brackets with a lot of these words. So instead of using curly brackets, so again, with curly brackets, this would have worked. So if I were to wrap this in curly brackets, so then now he knows like run this code block for this loop, this should work. I guess not anymore. Now you have to use the do keyword. So you see there's some big differences in Scala 3. That's why I wanted to do this video. Cool, and then that works as expected. Okay, and then really I want to print line because I want each thing to get its own line. So I'll do that. And you see 1, 2, 3, 4, 5. Okay, versus the older syntax. Okay, so again, older syntax. Oh, because you would have had to use parentheses there. That's what would have designated. So let's see if that would still work. So if I take off the do, but then wrap this in parentheses. Would this still work? Yes. Okay, so again, the old syntax still works, but again, you can take advantage of this newer, more succinct syntax. Okay, so for this, do that. Cool. You can even do this, where you can write little, in your for loops, you can write little if statements. Okay, where basically, hey, it's checking, hey, if this is true when you do the int. So for example, I could write here and then say, okay, for if, I modulo 2 equals 0, so that way it's even. So basically what it's going to do, it's going to loop over each number, check if it's even, and then if it's even, it'll print I. And this is referred to as a guard, because I'm kind of like checking on each number, and see, it only prints the even numbers. That's pretty cool, okay? That I like quite a bit, okay? Because that can make, doing something like a fizzbuzz pretty straightforward. Okay, now I wonder, can I do this? Else do print cheese. I'm just guessing whether I can do this, but it would make sense that I could do this. Okay. End of statement expected. Okay. Well, I tried. Try to see if I could push, how far I could push that syntax. Okay. Okay. Cool. And then here we say for do, and you're doing multiple if statements. Okay, that's fine. So you can have multiple guards. For expressions, we just kind of saw that a second ago. So you can, basically it's for, okay. And then this is gonna, the difference between this, when we're using the yield keyword instead of do means you're telling it to do a statement. Yield means like return a thing, okay? So I can, so the difference is if I did, instead of saying yield I times I, what I can do is then this expression, this becomes an expression that returns a value. So I can then just be like val hello equals this expression and then print hello. Let's try that out. Does it like it? And yeah, see, I get 4 and 16 because it only did it for the even numbers. Remember, it only looped over the even numbers. So 2 and 4, and then 2 times 2 is 4, and 4 times 4 is 16, and those got pushed into a new list. Okay, so that is pretty cool. It's kind of like I can do a filter and a map all in one. Okay, so I can loop over the thing, only loop over the ones that I want, and then return them with the transformations that I want. So that's pretty awesome. Okay, I mean, technically, yeah, I could just basically filter and map without using filter and map. So that's really cool. I actually really like that. Okay, so you guys get the idea. So yield, so do just means like to do a thing, so it's not necessarily going to return that thing. Like, and just to kind of demonstrate that, let's change this to do, and let's see what that ends up returning. Should probably get an error probably. Nope, I just get nothing. So because again, do, it's not returning the result. Yield, it'll return the result, so that turns a for loop into an expression. Okay, and again, the statements do things, but they don't give you back a value. Expressions will result in a value that gets returned at the end. So functions are expressions, and well, in this case, everything's an expression. Okay, and like that little like piece of clarity really unlocks what makes like really helped me unlock sort of like, okay, this is why we should like functional programming and why we should like languages that are built around functional programming, because then you can use those ifs and for loops in so much more interesting ways. Okay, so like that really kind of made that little insight really kind of unlocked a bit for me. So we talked about the match before, but look, so the match also has a more succinct case, and again, that's also an expression. So Let's try that. So we can say val hello equals match 1. And again, just looking at this real quick. One match. Okay. And then, okay. Yep, okay. So we can say match, but shouldn't be match 1, it should be 1 match. So 1 is matched with the following cases. So if the case it's 1, then it should equal 2. Case 2, let's make it equal 3. And case 3, it will return 4. And again, case where it doesn't match any of them, and again, is it just an enter case or yep, case? And then I'll return 5. Okay, so now if I do this, and then I print line hello, what's going to happen is that I'm going to match 1 against these possible cases, and it's going to return the value that matches. And that's really nice, because switch statements in another language, again, they're just statements. So you have to do stuff in the switch statement. You have to mutate something in the switch statement to really get something out of it. While here, I can actually have this, the match is an expression that can return a value. I mean, I could use it to do a thing. Okay, I don't have to use it as an expression, but I can. That's powerful. So I can be like, okay, it's the result of this, and I get unreachable case. So it's just complaining that since I hard-coded 1, it's always going to be so. But it doesn't give me the eventual right answer, 2, okay, because since it's 1, it matches, it gave me back 2. So it gives me warnings, because again, since I hard-coded 1, it's impossible that 1 will ever be 2, will ever be 3, will ever be anything else. So it's complaining that these cases are unreachable, which is fine. This is just an example. Okay. And then again, we have like case, we can use case classes, but we have to define a case class. But basically, a case class is a class where you can use inside your matches. So I can be like, hey, in case the variable is a person with a name, if the name, and then you can use guards, kind of like we did with the for loop. So I can be like, hey, if this is the case, and this, do this. And again, the little arrow helps you determine like, okay, this is the result. Okay, so that's pretty cool. Try catch, finally, I'm going to assume that pretty much works like what you would expect a try catch block to do. So like try means do this code, and if there is an error, catch it, and then finally would just mean like, hey, do this whether it works or not. Okay, because generally finally always just means either way. So I'm going to assume that that's what that's doing. I'm not going to delve too deep. And again, you have while loops. So you're just your traditional while loops. You can just do that now in one line. Okay. So again, basically this was the old way where I had my expression and then my code. You could still do that, but now you can also then use the do keyword. So these Scala3 differences, actually so far trying them out, I like them quite a bit. Okay, I'm glad I downloaded the new Scala. Again, I'm not going to get into traits here, but traits, Scala is going to favor composition over inheritance. So instead of creating classes that inherit lots of things, which I think you still can, but I haven't quite gotten there yet. But this is going to be more like Rust, Go, where you define groups of functions or groups of functionality that a class can have, and then you say, okay, well, you have these groups of functionality, and you denote these traits, and you say, hey, this class extends these traits, and then implement the functions accordingly for that class. Okay. Although I don't know, I haven't delved too deep into traits and classes yet, so I'm going to kind of save that for later. But I think we kind of went over some of the basic core syntax changes here in Scala3. And again, a lot of it's not necessarily change more than they've offered you a newer, simpler way of doing it. Where there is going to be change is with a feature that I have not played with yet, which is going to be implicits. So what happens with implicits, which is really kind of the idea is pretty cool. The idea behind an implicit is that you can have something that you declare as an implicit. So you say this is an implicit, let's say, argument, So basically, I've implied this cheese object, right? And if I have a function that takes in a cheese object, it'll see that it'll take a look to see if there's only one cheese implied, because it only works if there's one. So because this function takes in a cheese object and I've declared an implicit cheese object, I don't actually have to pass the object as an argument. It would just do it for me. Apparently, this was a very controversial feature in Scala 2 that some people felt was confusing. Other people felt it made things like dependency injection a lot easier, but a little bit more explicit and easier to kind of understand. Because if you ever use dependency injection, it feels magical. Like usually you have to use someone builds out some DI framework, or you use some DI library, and then what happens is you just kind of declare these arguments to your functions and they just magically get filled, and you're just like, how does it happen? With implicits, at least you declare these implied objects, so at least you know where they're coming from. And that's kind of like the benefit of that. So what they have done, though, is they've changed the syntax on that a bit. So let me see if I can just find that real quick just to show you. Implicits, union types. They've also enums are a new thing in Scala 3, so you can actually declare enums. So actually, here's an example. Enums are just like you're allowed to declare different possibilities in a sense. So you can say like, colors, and the possible colors are red, green, and blue. That's an enum, and allows you to sit there and say, hey, what this should give me back should fit within this enum, so it has to be one of these options. So it's a way of typing possibilities. So apparently you could do enums, sort of, but it wasn't an explicit feature before. But let's see here. The new implicit thing. Higher order, write your own map method, returns a function, anonymous functions, control structures, contextual abstractions. I think that's what we're looking for. Okay, no, but let's just hit the search, because I think the new thing is with the given keyword. Okay, so given instances are simply givens. Let's just see where it is. Alias given, an alias to be used for a given instance was. So basically, instead of using like the word before, you say like you declare an implicit thing. I think the new syntax is you would declare it as a given. So you're saying, hey, I'm giving this thing to any function or whatnot that takes that as an argument. So I could say, hey, given this database connection, and then any function that says it takes in a database connection, assuming that that's the only given one, it will just take that in. And that way I don't have to necessarily explicitly be passing it every time I use that function. But in the code, I can read that was given. So that's, again, a more advanced feature. I do eventually want to get to that, because I kind of really like the idea of that. And I do kind of appreciate why this would be an improvement. So overall, I'm pretty excited about Scala 3, and I'm really liking it. And I'm hoping this does rejuvenate the Scala language, because apparently, like, it seems like culturally, like, of languages that were seen as successors to Java, Kotlin has gotten sort of all the hype lately. They're both really cool languages. As you guys know, I just love programming languages and learning different programming languages and learning all these different sort of ideas, these semantic and syntactic ideas, and seeing how they're applied. But hopefully you guys enjoyed this. Yeah, let's write Scala. See y'all later.